The 1980s saw a major issue facing the entire planet. The ozone layer had a hole in it that was fast growing. So what took place? Does it still exist? Retrace our steps to the beginning. Although the sun is necessary for life to exist on Earth, too much UV radiation can harm animal and plant DNA. Thankfully, ozone molecules scattered throughout the stratosphere absorb around 98% of the radiation, which, through this process, are constantly disassembled and reassembled, maintaining a delicate equilibrium. However, two chemists named Mario Molina and Sherwood Rowland showed that commonly used chemicals known as chlorofluorocarbons, or CFCs, might upset this balance in the early 1970s. Three US-based firms created CFCs in the 1920s as refrigerator coolants. CFCs weren't hazardous or combustible like other options like ammonia or methyl chloride. Thus, they wouldn't catch fire or release dangerous gas leaks. They also produced excellent fire retardants, foaming agents, and propellant. The use of CFCs quickly spread to many commonplace things, creating a multi-billion-dollar business. CFCs don't degrade or interact with other chemicals in the lower atmosphere, but Molina and Rowland demonstrated that in the stratosphere, UV radiation splits them open, releasing chlorine atoms. These then combine with ozone and react, depleting it more quickly than it can regenerate. Thousands of ozone molecules can be destroyed by a single chlorine atom before the atom eventually reacts with another element to form a stable molecule. When the EFC industry realized they were in danger, they retaliated by attacking the scientists, even claiming they were KGB agents. Initial projections indicated that in 60 years, by sevens, CFCs could lower ozone levels. But by 1985, it was evident that ozone depletion was occurring considerably more quickly, particularly over Antarctica. Here, the intense cold and distinctive Antarctic cloud structure increased every spring. Researchers in Antarctica have observed a significant decrease in the amount of ozone in the atmosphere. The enormous scale of these losses was revealed by satellite data, and chemical analyses proved beyond a doubt that CFCs were to blame. Soon after, NASA created graphics that attracted attention from the general public and were televised all over the world. In the event that ozone depletion persisted, the incidence of skin cancer would dramatically increase, and photosynthesis would reduce plant productivity and increase disease susceptibility in crops, including rice, wheat, and corn. The world's agricultural output would decline and entire ecosystems would disintegrate. However, many lawmakers, taking into account current economic issues over long-term ones, conflicted over what to do. President Ronald Reagan of the United States and Margaret Thatcher of the United Kingdom were two unusual allies in the campaign to outlaw CFCs. Reagan, who had undergone treatment for skin cancer, and Thatcher, who was educated as a scientist, realized the necessity for quick action despite their overall aversion to government regulation. The United States and the United Kingdom led efforts for a global ban on CFCs, along with Canada, Norway, Sweden, and Finland. Representatives agreed to the Montreal Protocol in 1987, which mandated the swift phase out of CFCs and established a fund to help developing nations get access to cheap, non-oceanic ozone-depleting substitute. The only pact in history to do this. It was later ratified by every nation on Earth. Molina, Rowland, and Paul Crutzen, a colleague from the Netherlands, shared the 1995 Nobel Prize in Chemistry. The ozone hole started to get smaller when the use of CFCs decreased, and it's expected to close up completely by 2070. But the battle is not yet won. Since CFCs are strong greenhouse gases, the ban was good for the environment, but hydrofluorocarbons, or HFCs, which will take their place, are also effective. Even though they are typically less powerful than CFCs, FCs nevertheless retain more heat than carbon dioxide and are a factor in global warming. The Kigali Amendment, which stipulates an 85% reduction in global half-Cs by 2047, was introduced to the Montreal Protocol in 2016 to address this issue. By the end of the century, this might save up to 0.5 degrees Celsius of global warming. The Montreal Protocol serves as a blueprint for the resolute international cooperation required to tackle the grave threat posed by climate change in the modern period. What will it take for us to reunite once more is the question. Watch these videos or visit edtedcom/earthschool to see our action guide for next steps that you and your community may take. We have the know, how, and resources to protect the environment. Discover more and proceed to the next step here.